Welcome back. In our first video, we installed Rust and wrote our first program. Today, we are diving into Rust's syntax fundamentals, specifically variables, mutability, and data types. These concepts are where Rust starts to show its unique personality. So let's dive in. Our today's agenda would be the variables and mutability. Then we will discuss the basic data types that are used in this programming language. And third, we will then discuss constants and shadowing. And lastly, we will then check out the basic input and output operations that we can done in Rust. So now let's dive into this. So in most languages, variables are mutable by default. But in Rust, various things are done differently. For example, variables are immutable by default. This is a core part of Rust's safety policy. So let me show you an example of this. For example, define let x is equal to 5. It defines the variable x as an immutable variable. If we try to update it to value 6 and then try to print this value, then see what error we get. Rust c main.rs. So we got an error stating that cannot assign twice to immutable variable. So our compiler is flagging the variable x as immutable because the core syntax works as follows in this Rust programming language. The immutability that is added here is for the security concerns. It prevents accidental modifications and makes the code easier to reason about. So in case we have to define the mutable variables, then only thing that we have to do is to add a word mut before the variable name. This would make the variable x as the mutable variable, and hence this same code will work fine again. So let me show you this. I got an warning here. Let's now execute this. The value of x is 6. So our complete execution worked fine here. Let's now discuss the data types. Rust is a statically typed language, which means that it knows the types of all variables at compile time. Let's now explore the basic scalar types. So first of all, I would start with the integer types. Let's clear the previous codes and let me write declare an integer variable. So let a I8 is equal to -100. I8 points to the 8-bit signed integer. For declaring a signed integer variable in the Rust, you have to specify with the I8 keyword right after the variable name. So afterwards, let's declare another variable with the U8. U8 denotes the 8-bit unsigned integer, and An unsigned integer with 8 bits can only store values from 0 to 255, 0 to 255, and for the signed one, it would be minus 128 to 127. Alright, another another type would be I32. I32 denotes the 32-bit signed integer, means such a signed integer which would occupy 32 bits of memory. So as an example, let's set it to minus 5000. Similarly, unsigned counterpart also exists for the 32-bit U32, for which you can initialize with the unsigned number. So similarly, 64-bit variant also exists. Let E U64 is equal to, so this would occupy 64 bits of memory. So another type of initialization can also be made, like let E is equal to 42. Here the type inference would be done automatically, and for the variable f here, the by default it would be inferenced to the I32 type, similarly as we have declared the C variable, so it would infer to I32. Similarly, if we have declared the float type of variable, suppose I have initialized it with 42.23, then this would inference to the float type, which would occupy 64 bits of memory. So here the G variable would occupy 64 bits of memory, and it holds the float type of data. Now let me show you by printing the values of all these variables. For printing these, the syntax would be like this: println, and then under the double quotes write the braces, and then type the variable name. Suppose I have chosen the variable A. Now let's compile this, and then main.exe. So I got the value of minus 100, which was the value of A, like here. Similarly, I can print for the other variables as well. B, then C, then D, E, F, and finally G. Let's compile it and now print it. Yeah, so I got all the values now: minus 100, 255, 255, 5000, and 100K, then 42, and finally 42.23. Now we have covered integer types. Now let me show you the floating point types in detail. So let me create new file for the same. Let's now define main function again, and for initializing a float type variable, suppose float var, and this is type of F32 and it stores 34.56. Then so float var will store the values whose type would be uh, which will store the value in the memory of 32-bit size. Similarly, F64 variant also exists. So instead of 32, you have to write F64, and you can here define more precise value that is impossible to store in the float var variable because of the smaller memory size. Another variant exists for the scientific type notation. So where scientific, and so you can uh, initialize with a value, for example, 1.4 E6. So this actually denotes the value of 1.4 into 10 to the power 6. So scientific notation values can be written like this. For the 10 to the power, you have to write a letter E instead of that. Afterwards, you can then check with by printing all these values. Float var, then float var 2, and finally var scientific. For compiling, type rust c float.rs. Oops, float var was uh-oh, semicolon. To c float.rs. It's compiled now. Now write float.exe. So I got all these three values here. This variable is now printed in the detailed format. Defining Boolean type variables also very easy. You have to just uh, define the variable with a type bool. For example, bool var colon bool. This bool keyword will define the type as Boolean type, and later you can define either the true or whether the false. If you can't, if you haven't defined the type inference explicitly, the Rust compiler is smart enough to automatically type it to Boolean type by checking the value with which it is initialized. So let's check it by printing bool var bool var 2 rust c float.rs float.txt got both the values false false for the blue bool var and bool var 2. So this completes the Boolean type or study. Now we can study about the character types. For the character types, the variable occupies the 4 bytes of memory, and it is represented in the Rust memory as an Unicode scalar value, and surprisingly it can also handle emojis and characters from any language. For example, let's define a character. Let letter is equal to A, and I can also define the emoji like this, and then I can check it by printing what it prints actually. Let letter, and another is emoji. So got both the values, the character A and the emoji here. So Rust is able to parse both the characters and the emojis too. Now our next topic is constants and shadowing. The constants are immutable variables, as you already know, and they are evaluated at compile time and can be declared in any scope. So let me show you by the example here. For defining the const, you have to define it via the const keyword, and just for the standard practices, you have to type the constant variable in the uppercase format. So for example, I initialize it with a 10,000 value, and while defining the mathematical constants, you can ab- absolutely refer to the standard practice of writing the variable name with the uppercase letter format. Suppose I defining here the value of pi constant. So the pi value is around 3.1415. So hence it is easy to initialize the constants, but you have to remember that constants are immutable. So mutability should be avoided at all times. Otherwise the error would be thrown, obviously. Let's now discuss the shadowing. Shadowing is different from the mutability. In the shadowing, we create a new variable each time. This is useful when we want to transform a value but keep it immutable. So let me show you by an example that let x is equal to 5, and in the shadowing, if we have to modify the value of x, suppose I want to add plus 1 in the original value of x, I have to store it. I have to firstly redeclare the variable x, and then in that I would initialize with the updated value uh, with which I want to store it in the updated value of the x. So now the x would store the value 6 because 5 plus 1 is equal to 6, and such redeclaration can be done as many times as you wish. Suppose now you have to multiply it by the 2. You can again redeclare it and initialize it with the updated value here. So this is the actual shadowing concept, that you change the value of a variable by redeclaring it with a new value. Thus, now it's time to compare the both the mutability and the shadowing, that for the for defining the mutability of a variable, you can either uh, explicitly inform with the mut keyword. Otherwise, you can take use of the shadowing for changing the value of a variable like this, y is equal to y into 2. So there are two ways to update the value of a variable in the Rust. First one is the mutability via the mut keyword, and another is the shadowing concept, which I explained here. So this completes the mutability and shadowing. Next, I will help you learn the basic input, output, and string methods. So now let's dive into it. Let's create a new file for the same, string and io practice.rs. fn name, let name is equal to Alice. So when defining with the string value, you have to write the values in the double quotes and initialize it with the variable with which you want to. For defining a string, you have to follow this. Type the necessary string value in the double quoted format. Let me define two more variables. First one is age and another is height. Suppose I want to print that Alice is of age 30 years and her height is 5.7 inch. So here, as we can see, that we have to pass the string with these values. So to actually print such a dynamic values into the terminal, you have to follow this println. So instead of the hard-coded Alice, uh, write the braces. Similarly, at the place of age 2, and similarly at the place of height as well. And then type the variable's name which you want to see that to be filled here. So whatever variable name you would keep here would go to the first braces. So type the name so that it should go at the first place. And for the second one, I want age to be written here. So type the age at the second place, and lastly the height would be shown. So on compiling and execution, this would print the same as the Alice is of age 30 years and her height is 5.7. If the name, age or height is updated, the updated string can be printed without any additional effort. So this is how the string parsing is done in the Rust. So first one is just the basic interpolation. There are another variants as well. So another variant is the positional arguments. For the positional arguments, it can be done like this. You have define the positions of the variables which will go in the uh, required braces. For example, the name actually denotes to the zeroth position and age denotes to the first position. So name would go in this brace and in these braces, and uh, for the first index the age would go in at this place. So on printing, this would for these inputs, it print that Alice is 30 years old and Alice is learning Rust. So this is the positional arguments variant of print formatting the strings. Another variant is the named arguments, and named arguments can be utilized like this. Whatever variable you want to be passed into the string, just type those in the braces and hence you are all done there. There are further formatting options in the strings. Lastly, it is the following. Suppose you have to, in the string, you want the uh, decimal values to be printed such that its precision would be up to 3 digits after the decimal place. So for that you can write this. So for the given value it would print 3.142 because the 3.14159 actually rounds to the three places, and, and the value becomes 3.142. For the binary and hexadecimal values, suppose the 10 you want to be printed its binary value, and for the 255 you want its hexadecimal value to be printed. So that can also be formatted by the typing :b and :x. So now let's check this. Rust C string and IO practice.rs. Let me check for the semicolons. Seems fine now. Got an error here. Main function not found in create. Got it. I haven't saved the file. That's why the error occurred. After saving the file, it successfully compiled. Now let's check it by executing this string and practice dot exe. Yeah, though so the first string is this. Alice is age 30 years and her height 5.7 inch. Second is Alice is 30 years old and Alice is learning Rust. Third is Alice is 30 years old and 5.7 feet tall. Then pi is approximately 3.142 and binary and hexadecimal values for these values. You can check it by manually uh, converting it into binary and hexadecimal values as well. So thus this completes the string formatting. Let's now check the input outputs. So for the input and outputs, suppose you want to read the input as uh, your name to be read in the form of input. So for that, for example, a prompt come to you before that enter your name and for reading the input, uh, firstly import the necessary package for the input output. That package is stdio. Before reading the inputs in the terminal, I import the stdio package and later define the name variable so that whatever you type in the terminal that would be stored in the variable string new. So in this name variable, our whatever we type in the terminal, these would be stored in the name variable. Now write it as iostdin dot read line and mut name dot expect fade to read line. So what it do here that it is reading the input from the terminal, whatever you typing, and storing it into the variable name. And if the input reading fails, it would prompt that reading line is failed, and this message would be printed in the terminal. Now let's check it. Print ln hello, welcome to Rust. Name dot trim. Trim function here will remove the any white spaces characters that may you have typed into the terminal while providing your input. Now let's check it. It compiled successfully. So here I'm getting the prompt that enter your name. Suppose I write tech tutorial. So hello tech tutorial, welcome to the This is what I was intended to print, and hence I got the required string here. So thus this covers the basic input output here, and afterwards we will check some practical examples for the basic mathematical conversions so that you can grasp the uh, data types better way. Now I'm going to type the code for the basic temperature conversions so that you can grasp the ideas of data types and input output a much better way. Let me define another file temp converter.rs. To fast forward this, I am writing here the complete code. So let me explain it. These three print functions do that. It's printing the temperature converter and providing you the options to choose from the Celsius to Fahrenheit and the Fahrenheit to Celsius. Then your choice is then read in the terminal that whether you are choosing the first option or the second option. Now, after your choice, the number will be taken as input from you. For example, if you have chosen the first option, you would provide the number that would point out the degree Celsius that you want to convert it into the Fahrenheit. So here you would provide the value of Celsius or otherwise Fahrenheit if you have chosen the second option. So in this code, what's happening is that you have been provided with the two options that whether choose the first option which would convert the Celsius values to Fahrenheit values, and second option would be for the Fahrenheit to Celsius conversion, and your choice would be stored into the choice variable. If your choice is not in the range of 1 or 2, then or whether the input reading fails, then you would get the error that failed to read line. And if your provided input contains other characters which is not actually a number, then this would fail on the parsing here and you would get the prompt there. Please enter a number if you do not provide a complete integer formatted string. So after your choice formatting, you would be prompted to enter the temperature value, and your temperature value would be stored in the temp variable. Here as well, if the input reading fails, you would be get an error that failed to read line. And again, here the temperature input is formatted so that your input can be verified on whether the provided number is actually a valid number or not. After that, your choice is analyzed here in the if block. If your input choice was 1, then you want that your the Celsius to Fahrenheit conversion, and it would be done via this formula temperature into 9 divided by 5 plus 32.0, and your converted values would be printed here. Else block will execute when your choice would be second one, Fahrenheit to Celsius. Here, this formula would be used, temperature minus 32 into 5 divided by 9, and the corresponding converted values would be printed here. We can check it by compiling and executing it. Rust C temp, sorry, Rust C temp converter dot rs. Now execute the executable file. So now I got the prompt to choose whether the input 1 or 2. Let me choose the first option. And for the temperature value, uh, let's choose the 50 degrees Celsius. So the converted value of 50 degrees Celsius is 122 degree Fahrenheit. We can check it for the second option as well, Fahrenheit to Celsius. Choose the option 2 and provide 122 to check that whether the converted value comes as 50 degrees Celsius or not. So yeah, 50 degrees Celsius came here. So our formula was correct. It is proved here. So now it's time to conclude this. Today we learned that variables are immutable by default, and for the mutability, we have to either use the MUT keyword for mutation, or we have to use the shadowing. The basic data types that we read was the integers, floats, booleans, and characters. Later, we learned about the constants, where we knew that these are the values that never change, and the best practices regarding this was to define the constant variable in the uppercase format. It is just a standard convention. You are free will to use the lowercase or the camel case letter variables as well for the constant. And we learned about the shadowing for creating the new variables with the same name. This is the another way to ensure the mutability of a variable. And lastly, we learned about the basic input output with the println and the stdio variable package with which we can read the inputs. Some of the best practices that you have to keep in mind that prefer immutability whenever possible for the security of your code base, and use the descriptive variable names for the enhanced readability, which indirectly helps us in the debugging, and leverage the type inference explicitly, but annotate it so that it can ensure the clarity. Use the constants for the numbers which you often use it, and shadow variables. Use the shadow variables instead of the mutating, where whenever you are about to transform the values. So great job. You now understand Rust's fundamental building blocks. In our next video, we will explore the compound data types like tuples, arrays, and then dive into Rust's most famous feature, which is the ownership system. As an homework, you can create a simple program that calculates the area of a circle using the constants for pi. Try using both mutable variables and shadowing approaches so that you can master over these two concepts. If you have any questions, drop them in the comments. Don't forget to like and subscribe for most Rust videos. See you in the next video. Bye.